My name is Pierre, it's great to meet you. I'm French, as you can hear from my voice. I've been in Seattle for 8 years. My background is in decision sciences and structural engineering, so if you need someone to build a house, I can also help you, apart from building agents. And I had a company before that called Notable, which I sold to Confluent, the Kafka company, where we raised 25 million overall. So this is my second company. And I'm building that with very smart people, one being the co-creator of Parquet, the file format, if you're familiar with that, and also Apache Impala, which is a SQL engine. And the former head of ML of Twitter and Airbnb for 4 years each. So the talk is about really talking about multimodal data, pipelines and orchestration more than agents itself. We're going to talk a bit about agents, at least a couple of agents in production. But I don't want to spend too much time on diagrams about what is an agent and multi-agent orchestration, all of that. Everyone talks about that every day. It's a bit boring to me right now. But unstructured data is everywhere. That's what I care the most about. With agent now taking over voice and images and generation of audio as well, it's just going to keep accelerating. So building a startup or being aware of the issues with building multimodal agents is quite important. And what's very interesting with multimodal data is if you take, for example, a single media file, depending on how you use it in your workflow, you can actually produce a lot more data with it, compared to just structured data when you're just going to aggregate it in a cache, let's say in Redis, and then serve it in your front end or your application. If you think about the video, you might chunk it into frames. You might then extract the audio. You might then transcribe the audio into text. You might then create embedding indices for all those things. You might actually feed that into an LLM to generate even more videos and even more audio. And so you can think that if you have a small clip of video of a couple of 100 megabytes, you can generate gigs of data out of it. So the question is that if you build a multimodal agent or multimodal application, how do you handle that at scale? What do you decide to store? What do you decide to cache? How do you scale the pipeline for building that application? And today, if you have built a multimodal AI agent, what's built a multimodal AI agent? Let's say an agent that produces some text, document, images, audio for people. Who wants to build one? What do you think is the biggest challenges when you look at this, if you had thought about what you would use to build it, for example? Data. What about data?
Like orchestrating.
Okay. Standardization of data, in terms of what? In terms of format, in terms of?
Contextualizing it in a business. You just give a lot of data from various sources. It makes sense of the data.
So contextualizing the data for the application. Anything else?
The sizes of the limits of the LLM at this point, like sometimes you need to shrink it or fast and it do something to send it to the lab or anything more.
Yeah, so what
there's latency involved.
So issue with latency, performance, what to chunk, what to use. Okay, so we're gonna talk about that. But that's pretty much the stack you're gonna use if ever you think about building a multimodal AI agent or any applications involving that. Usually you have your data in S3 storage, in S3 or RDS or whatsoever. And then you're gonna think about some pipeline for that data, like video image processing using FFmpeg or PyAV to do transcoding or any other things, which transcoding is really expensive for instance, in terms of compute. You might use Whisper or others to transcribe it. You can do that locally with a virtual solution, or you can pay some SDK. Embedding pipelines, you're gonna use some vector. DB or not, most DBs have a vector support anyway. Text management, the rest is pretty much typical to any AI app applications, like tool orchestration, business logic, and monitoring. But what's really the big additional task with multimodal data is thinking about the file type in the first place. You don't have file type when you think about structured data, just a bunch of floats. So if you think about file type, it's like, okay, you receive a bunch of files from videos from your customers and they want to upload the MOV or MP4, or they want to upload, not just PDF, but actually text or markdown, all of that. How do you standardize that? About some standardization, for example. Separate storage. So you have all that data landing in your bucket versus you have, for example, your application table being in MongoDB, or you have Supabase, or you have your structured data being in RDBMS, how do you bring that together in memory to orchestrate that? So you have a lot of data movements, which means you have a lot of constant materialization and reprocessing. Because let's say if you chunk your video into frames, because you're gonna run an object detection on your frames and then feed it to an LLM to say, hey, here's a horse walking, please put bounding boxes around the horse so I can kind of feed that as an aid, to the agent, and the agent will like, oh, the detection of the horse is not right, let me change the JSON and the bounding boxes, boundaries, and fix it, and then that could be an application. It's very common. You look at object detection and on the street, they start adding LLM to typical ML to just try to enhance that. It's very expensive. You have to decide which frames to send to the LLM. There's a high latency. And once you do the process once, you lost all that in memory materialization. All the frames that were extracted and generated at runtime from the video to be fed to the object detection model, to be fed to the LLM. What do you do with it? Like, do you want to keep them? Do you want to cache them? Do you want to reuse them? And so you have all the infrastructure concern you talked about, which is latency, caching, scaling, and a bunch of others. And so when you build a multimodal application, most of the users care about being near real time, whatever you are building. Just a front end, an API, an SDK, the UI. People really want the information to be as real time as possible. And you have all those now new transformation and data processing that are more than just aggregated metrics that you cannot store in Redis if you are doing structured data. So you think about, you are chunking your document into text, your video into frames, your audio into smaller sample, because that's the only way to transcribe them with the SDK model that you are using, because there is a limit. That takes some time. You have to think about transcription, you have to think about indexing and embedding, you have to think about your retrieval queries and your materialization of your document. Let's say you build an application that is about a multimodal LLM that is going to scrape index all the YouTube videos and podcasts, and out of that, which is a company doing that, and out of that basically providing a search experience. What you're going to do is I'm going to search for, tell me about how to build an LLM, and you get a video which gives you a short clip of a couple of YouTube videos put together. That takes a lot of time to rematerialize that media from the search query you run, to identify the source video, to then build a short clip out of that and send it back to your front end. So there's a lot of optimization to think about in all that aspect. But then there's like a good news now, which is okay, maybe I don't need to care about all of that, because the LLM like Gemini now is very natively multimodal. It takes a video as an input. People say, okay, everything is solved, I don't need to chunk into frames anymore, I don't need to extract the audio. Because actually that's what the SDK, that's what the LLM does. Behind the scene, the service, what it does, when you feed it a video, first you have to use the file upload. So it's not as native as just, passing directly let's say, a sequence of frames or a string to the SDK. You actually have to use the file upload to upload the video, because behind the scene Gemini is going to do the chunking of frames and extracting the audio to analyze it. So yes, maybe you are removing some of the concerns, but you're actually giving away the flexibility for your application to do what you want, because you don't know if the LLM is going to now make sense of those frames, of those videos, of that audio. Maybe you just wanted the LLM to look at some key frames of that video, not the entire video, because now you wasted a lot of token, because it costs way more money, the latency is higher, and maybe the LLM didn't need all that entire series of frames to make sense of the information you are feeding it. So yes, you can, assume that the SDK, the agent SDK or the LLM provider like OpenAI, Gemini, and others will keep going up the stack to try to hit the market and really provide more value. But at the end of the day, if you use some of those abstractions, you're gonna more and more give away the flexibility that you want for your application. Another good news, as you can now know from the previous slide, it's not that much of a good, at least to me. A good way to get started, and I'm not gonna quote, there's a big company doing that, making a lot of money right now, and I was talking to them, and they're completely moving away. They're product market fit, they're pretty well known, they're doing like interviews, they're automating interviews with multimodal agents, and they used to use most of those companies an SDK. So they have a very simple orchestration pipeline, and then just give away all their business logic to those SDKs, which means let's say you have an agent interviewing a real human. So imagine the opposite of me boss. The complete opposite of me boss is like, okay, you're a software engineer looking for a job, you're applying to this job, you're gonna jump on a call and you're talking to like a fake avatar, which is just an LLM. And that company basically were relying on most of those tools. And as they were scaling, they realized that issues, retries, they didn't have visibility into the logs, they're spending a lot of money because they do not capture each step. They don't have lineage, they don't have versioning, they don't capture each step of the pipeline. And with multimodal data, it's super important because you need that visibility into the intermediate steps to know what were the different calls. Like, what did the object detection produce? What did the first and the third and the fourth LLM, if it's a multi-agent orchestration, produce? Where did the issue take place? Which SDK failed so that there was a bug when that person talked to that agent at that time? It's very difficult. So those SDK will send you to pay for the service and go on each specific data store that they have and whatever. So they completely re-architected everything to build a data foundation in order to say, okay, we want to store now every step of the way. But it takes a lot of time and people who have the knowledge to build that, because you have to spin up potentially your own vector DB, your own RDBMS, your own orchestration service, and a bunch of microservices, and try to capture each step of the way. Say, okay, I'm taking a snapshot of this, I'm going to store it in the blob storage, I'm going to keep track of the metadata of when that multimodal data was produced in RDS, and so you're going to try to build that observability layer for yourself. And so the problem when you use those SDK is the following: is you have the structured data sitting in RDBMS that is persistent, version index, and queryable. You have still your media sitting in object store and a cache, for example, if you have a file-based system as a cache, or like you have the video or the image on disk. And you have your AI pipeline, whatever you use, simple cron jobs to some Intel solution that are basically stateless scripts. And so if you want to, let's say you want to build an MCP server that is going to be able to be brought to any agent to say, you have an agent running, does something, whatever. Say, I want to enhance that by bringing an MCP server as tool that will do some video processing. And you just build that MCP server. This is all you need to do and code that MCP server to make it production ready. You need to manage the videos, inputs, ingestion, that you have to chunk into frames. If there's some document into text, from those videos you're gonna extract the audio that you're gonna have to chunk, because like I said, Whisper, for example, there's a limit to how much you can send to it, so you're gonna have to chunk the audio from the video and transcribe them and then recompose them together. You're gonna have to index all of that. You're gonna have to manage the embeddings. The big issue with the embeddings is how do you maintain them? Let's say tomorrow I'm adding like 10 more videos to my knowledge base. Or imagine, you all know the company Glean, who does like Twitter, Wikipedia, on all the context. The biggest pipeline that they have is basically being able to maintain the embedding up to date. Because every day people add new JR tickets, they write new emails, they write new Slack messages, there is 10 more documents that were added or that were removed. And so tracking basically all that knowledge base and how to maintain your embedding index is also a big topic. And tool definition and all that stuff, that's pretty common to most applications that are not multimodal as well. Any questions so far? Now I'm gonna get into actual examples. So this is an example. You can go look at the Git repo if you want. It's completely self-hosted. You can launch it yourself. I think for this one you need an open API key just to try it, but you can, I think when you sign up you have like $5 for free or something. But what does it do? Basically, there is a front end here. I mean, just look at the repo if you want more details. There's a front end here, and you can go talk to it and say, hey, here's my video. Can you give me the key moments of the video? And it will spit you out the key moments of that video. You can ask questions and say, show me when, I don't know, when the cat is crossing the street, and it's going to search the video and show you that moment, and you can do a couple of things like that. But this is a good example of a stack that will give you, for example, multimodal agent, but with the multimodal capabilities being brought as MCP server, which I think is a pretty trendy topic, and I think it was a good example to show. And it's scalable, you have observability, you have versioning, I'm going to talk about it, you have lineage, so that covers really everything I just went through, from handling the data storage concern, caching, the orchestration. And here I'm using, of course, Pixeltable, which I'm here to talk about. I'm using OPIC for the trace, which is open source as well by CometML. It's using FastMCP to spin up the MCP server. It's using FastAPI, agentic, and just React and TypeScript for the front end. Any question? So now I'm gonna talk about building another example with Pixeltable, which is basically here to talk about tackling some of the challenges that I discussed. So Pixeltable is an open source Python library that gives you storage, indexing, transformation, orchestration of your multimodal data. So the big difference in terms of the fundamentals of what it is we unify storage, orchestration, and retrieval. So you will not see that out there, because we have the stance that if you actually have a data-centric approach to multimodal data, you simplify a lot of the concerns that I described, which is you don't have to worry about what do I track and when. You don't have to worry about how do I version my intermediate steps. You don't have to worry about, once you have your application in production, how do I get observability. You don't have to worry about rate limits for the API calls you are making to your LLM, because someone is like bombarding you with a batch of 20 videos and you're like hitting rate limits. So you don't have to worry about a lot of things. You don't have to worry about embedding management. And so I'm gonna show you what it looks like. There are 4 core principles. The first one is unified data foundation. So it's like a table interface that allows you to store, reference, and leverage any data types. So imagine a database that has multimodal data types: document type, audio type, video type, JSON, array. I think I'm missing one of them, plus all the typical ones. And so you can actually store any data in Pixeltable like if it was in a typical database. So let's say you're gonna work with a video, you just reference the file sitting in S3, and now you have access to it with a local path. And so you can actually transform and orchestrate that video within the database itself. And I'm gonna show you how it looks like. So let's say I've created a table in Pixeltable, and what I want to do is to use an object detection on that image. What I'm going to do is I'm going to add a computed column. What is a computed column? Is a dynamic column that's going to be populated as I insert data in my table. So think about a row-based execution. I have a table schema, that's my input to my orchestration, and my computed column are the output. So every time I insert, let's say, an image, here I created a table. It's a table that is persistent, versioned, and I have a pxt.image. That means I can reference or insert images into the table. And I have enhanced that table with a computed column that's going to leverage this UDF, user-defined function, which is just a model that I've built in, but you can bring anything you want. And I'm going to declare that the input to that UDF is the image table.input image, which is just the reference to the column. By doing that, I've done what is typically called declarative syntax. It's just declaratively declaring, like, what is my DAG? What is the orchestration of the data that I want to define? I'm just saying, on this image, apply this UDF and name the output object. I'm going to show you the embedding in another context. And I'm going to show you another context as well. So let's look at another more concrete example. This is another example of a multimodal infinite memory agent. So you can try it at agent.pixeltable.com. The entire code is available. Same, you can completely spin it up on your local machine. I use some cloud-based LLM, but you could use completely local LLM for that. You could just have to swap Whisper by OpenAI by Whisper local, and you could use like VLLM or Llama to use a local LLM instead. What does that agent do? That agent basically provides you with a way to upload document, images, video, audio. It will chunk them as needed. It will index them in real time, and it will serve them as tools to the LLM as well. So let's say I'm not going to demo it to you, but you can trust me or go look at it. If you upload a video, it's going to maybe take a couple of seconds, and then I will ask a question, and it will have the context of that video, both the frame and the transcription, if there was audio, available for the LLM as context secret automatically. And normally that requires a lot of orchestration and pipelines definition, because we went through all the steps that we need to do that. And so to build this application, I'm going to show you that this is basically the entire DAG of the application, but I'm not going to go into details. But this is what happens if you ask a question, it goes to the LLM, go look at the tool, etc., etc. But I'm going to show you a bit of code snippets to put Pixeltable in practice a bit. This is the structure of the repo. It's basically just one Python file that unifies storage and orchestration at once, because that's the definition of Pixeltable. Endpoint, when I'm using Flask, you can use whatever you want. Function, I'm just storing my UDF. Config is just my static variables. And I just abstracted the front end, which is pure JavaScript in the example. And if we look at the setup, and let's say we just take the media processing. So I'm just taking here what happens in the UI I just showed you if I upload a document. And this is only the code you need to do everything I basically described in this talk. I'm creating a table here, and that Pixeltable table will store a reference to the document that I'm uploading. And here it's completely arbitrary. I just decided that for my application I wanted a UID because I want to track, that document is coming from a specific user or whatsoever, the timestamp, the user ID as well. So this is completely application specific. It's what you will do store normally, let's say MongoDB or whatever you are using for application database. So great, I have my table that will store my document when the user uploads them through the front end. So I figure out data store here. We have data storage for the application and for my document. Now we want those documents to be chunked. So I'm gonna create a view. That view is basically, in database, it's called implicit lateral join, or I think it's called an explode lateral join. But basically what's happening here is a view is just a materialized table, which means that you are referencing the fact that this view will be materialized based on this table, and it will operate this operation here, which is a document splitter. It could be just a query, it could be anything. Here I decided to split the document. So you can see that I'm referencing the document column. Everything is just declarative. So I'm just saying this is the operation I want to do on this column. This is the output.